Hello and welcome to another session of Hive series. So in this session, we will see how we can handle the schema changes. So imagine this scenario. So you have a Hive table and you're getting this data, and now your Hive table has some particular schema. Now the source team has made some changes to their schema. So basically they have added a new column or they have dropped a column. Now every time they make some changes to your schema or the other source schema, from your end, you will also have to make the same changes to your Hive. If you don't make those changes, then the data might get messed up, right? And then we will see how it happens. So what we will do is we will try to replicate that scenario here and see how Hive is behaving, and then we will talk about what what we could have done differently so that these schema changes can be handled very effectively. So we are here at the MySQL. So we have a table called test which we have created. So it has three columns: ID, name, and city. So let me first delete the data from this table if I have any data. So I might have added some data while testing. So we don't have any data now. So what I'm going to do is I'm going to insert some data into this table. So I have the insert statements here, a simple insert statements, and I have inserted this data. So let me just query this data. So I have IDs from 100 to 104, 100, and the name John, Pooja, Michael, and Jesse, and these are the cities where they reside. So I have this data. Now what I want to do is I want to import this data into HDFS. Now we know to import this data into HDFS, we can use scoop, right? So we can write a simple scoop command to import this data into HDFS, but this data, this table is going to add more and more data. So this is basically today we have four records, tomorrow we may have two more records coming in. So this is basically kind of an incremental append or incremental load. So for that, a better way to do is to create a scoop job, right? So I have this scoop job here created. So you have a scoop job. This is my job. I think we already have job one. So let me change it to job five. So this is my scoop job. I'm connecting to the JDB using the JDBC drivers. It's in retail underscore TB. The table name is test. We don't have to use split by here actually, because we are just taking one mapper. So we didn't need to do any split by. The target directory is test3. It's an incremental append, and the column is basically ID, and the last value is 0. So this is a scoop job. So let me go ahead and execute the scoop job first, right? So the scoop job is now created. Now what we have to do is we have to execute the scoop job. So I will say scoop job execute, and I have to give the name of my scoop job, which is my job file. So it asks you for your password, give the password cloud area, and my scoop job is going to get executed. So it is going to import this data from MySQL into the location which is specified. Great. So my scoop job is now executed. So if I go back and check this directory, right, I should have this data, right? I have one file. So let me go ahead and get this file. The small file which should contain just four records. So we have all these four records. So now what we will do is we'll create a Hive table on top of it. I have the Hive table query here. So we are using the table called as test1. These are the ID, name, and city, the column names. And so this is the location. This is where our scoop job is inserting or loading this data in. So let me go ahead and query this Hive table or create this Hive table. So the Hive table is now created. So if I query this Hive table, I should see those data. and the MySQL is our source table. So in the source, we have some data, and our scoop job is running, which will import this data into HDFS. And then using our Hive table, we are basically querying that imported data. So this is, imagine this is something which is going to run every day, schedule every day. So this is good. It is, we are doing it correctly, and things are running fine. So what is going to happen is, let's say the next day we have four records, right? We have two more records that gets inserted. So what we do is, our source table has two more records. So if you do a select, you will see that now it has six records. Now once this data is inserted, we will have our scoop job. Our scoop job is going to run, and our scoop job is going to execute, and because it's an incremental append, it is going to bring those two records and insert into the location. So now those two records will be available in that location, and then your Hive is going to query those two records. When you query the Hive table, you should get those six records. So this is the normal data flow that is happening at the system, right? So let's just wait for this query to get completed, and then we will verify this. So we have the job, scoop job executed, and this is the place where we have the files being inserted or loaded. So as you can see, this is the new file that got added, and it should have those two files or two records that got inserted into the MySQL database very recently. So these are the two records that we inserted. Now the same thing will work for Hive as well. If you query this, now here we had data till 104, the ID 104. So you should have the two more records. So this is absolutely great. There is no issue here. Everything is working perfectly. Now what is happening is, if you look at this, this is our source table. So what source table has done it, they deleted this particular name. Okay, now this particular column name, they have dropped it. So let's drop this. So we'll say alter table test drop column. This is name. So we have dropped this column. So if you query this table, right, we have just ID and city. So New York, Mumbai, London, Cochin, Mumbai, and Cochin, right? So this is the data that we have. So the change has happened at the source side. Now what will happen at the target? So if you go and query this target, so it is still showing those three columns data, which is anyway, it is fine. That should not be a problem. But let's say we have inserted two more records here. So now here we don't have name, right? We just have city. So let's say we have this value, maybe let's say that we have this value as 107, and we have this, let's say we just insert mobile. I want to insert one more record here. I will call it as New York, or let me call it as London. So we have two records here. So when you do a query here, you will see, like, we have eight records. So the next step in our pipeline is our scoop job, right? So we'll have to run our scoop job. So let's give the password here. Let it ask. Okay. So we have the scoop job running. Now this scoop job is going to take those two records which are recently loaded, and it is going to put it in the HDFS location. All right, so we have this scoop job successfully loaded, so let's go ahead and check this data. So we have the new file here. So if I do an HDFS here, and I get this, I should see just two records, but at the same time, we'll only have two columns instead of three columns. So this is fine. This is what we have expected. So there's no trouble here. The trouble comes in the Hive. So when you query this table in Hive, you will observe something here. Now you see here, this is supposed to be your ID. This is supposed to be a name. In your two records that got recently added, so you have name as Mumbai and London. This is not correct. The name is not Mumbai. There's no name. We have dropped the name, but Mumbai is basically your city. This value should have been here where you see null. This value should have been here where there is null. Now this happened because we have a schema change at the source and we did not make any changes at target. What you can do is you can create another table which can refer to this location, and then you recreate this table and basically load this data from that table into this table. But that's something we can do. But there is a better way of doing this. We have to make use of Avro file. Now remember, during our file formats, I mentioned that Avro is something which helps in schema changes. It's very good in schema evaluation, right? So let's understand that with an example. It's time for us to make use of the Avro schema evolution capability. Let me go back to this and let me see what tables I have. So let me create a table again. All right, so we have a table called test stage, and we are going to insert this data into this test stage. So we have these four records. So what I'm going to do is I'm going to go ahead and insert this data. So if I do a select star, I should see this data. So this is great. So we have this data. Now the next thing that we want to do is we want to scoop import this job, right? So now when you scoop this, import this job, we have to make sure that the data or the file that is generated is Avro. So we need to import this as an Avro data file. So here is a scoop job that will create. So let me call this scoop 6, my job 6. So we are doing an import, we are connecting it, and we are basically doing an incremental append. Check column is basically ID. We are importing this as Avro data file. Now this is very, very important. You have to import this as an Avro file because Avro file supports schema evolution. If you import this as a text file, this will not work. You have to import it as an Avro file. So what I'll do is let me go ahead and let me clear this up first, and I'm going to execute this. My scoop job will get created. Yes, it got created, and I'll straight away execute this scoop job. All right, my scoop job is now executed. So let me quickly check this directory. This should have this Avro file loaded. So you can see here the Avro file. It has imported it as Avro file. Now what we have to do is we have to create the Hive table on top of it. Now, when you create a Hive table here, the difference is you have to put the schema in what is called as .absc file. Instead of passing that schema while creating a table, you basically mention the location of a file, and this location you should have the .absc file. The absc file will contain the schema of this table. Now, you can basically Google and check for the format of the absc file. Or what you can do is when you do a scoop import, you know that there will be .java file that gets created, but there is also something called absc file that gets created when you do a scoop import on Avro data file. So if you look at this file, it will contain the schema details. So if you see here, these are the fields. You have name, which is ID, and then we have the type, which is integer default values and other stuff, right? So similarly, we have for name, you have for city, right? And here it specifies this table name. So this is a file that you have to pass instead of the column names. So the schema for the table you have to refer from here. So let's copy this file to a Hadoop location. So I'm copying this to user Cloudera. The file in the user Cloudera Hadoop location, and this is the contents of this file. So now what we have to do is we have to create a Hive table. So let's create this table. So we'll say create table. Let's create an external table, and let's give it a name stage 1, text stage 1. Now normally we would have given the column names and other stuff, but here what we'll have to give is we'll give as row format 30, because this is serialization, right? Because we are using the Avro file, so we have to use the Avro serialization library here, so which is in org Apache Hadoop x32 Avro. This is a 30. Now you don't have to remember this. This is something that you can get it in Google or from the Apache website. So don't try to remember this. If you can remember, that's great, but it's not necessary that you have to remember this. Now we have to store it as Avro. Location is let's say user cloud era. This is where we want our data to be. And here, this is important. You have to mention the Avro schema URL. So you'll say Avro URL. So this is where you have to mention the Avro schema URL. So where do we have this Avro schema URL? So this is the location of the Avro schema. So we have to mention this. So now what happens is the table is going to check the schema available here. So whatever schema which is available here, your Hive table will use the same schema. So if there is a change in the schema, all we have to do is we have to change it here. Once we change it here, the updated schema will be referred by the Hive table. All right. So let's go ahead. We have this data. We have the table created. Let's check this. Seems like some issue. All right, the issue seems to be something different here. So if you see this, this is I'm at the edge node. If you see here, I have three records, three columns here: ID, name, city. But at the HDFS location, I somehow have just two records, two columns. Probably this is something from our previous example. So I'll have to copy this again to the HTML location. I believe I forgot, I missed copying this, so that's the reason why you end up seeing this. Okay, so I guess I'll have to first delete this. So let me go ahead and delete this. Okay, so let's just verify this one more time to make sure that we have the right file here. Okay, we have the columns, all the columns here, so we are good here. Okay, so we have this data now. This is a new schema that we have, right? And let me go ahead and execute the Hive table. Now, again, this is a good example as well, even though we did mistake. So if you look at this, where we in the Hive table. So when we did a select star on stage one, because it refers to this schema, the schema we had just two columns, right? Now we have corrected the schema. So if you go back and check this, now we have the right results. So as we change the schema, so if there was a change in the schema, you just update this AVSE file and everything will look good, right? So earlier we had just this records. Now we have corrected the schema and it all looked good. Okay. Now what we'll do is we will delete this data. We'll delete a column here. Alter table name. So we will drop this column. And what we are going to do is we are going to insert two values. This is ID city. Values would be let's say 107 would be London. Let me add it as Hyderabad. All right, so we have this data. So now what we'll have to do is let's execute this scope job. Okay, I'm going to execute the scope job. So this is scope job is an incremental job which is going to retrieve those two records. Now remember what happened here is that we have a column dropped, right? We deleted a column from the source side. So the scope job is going to retrieve those two records, but those two records will have only two columns. The column name is basically missing. And this is the earlier scenario we have seen, right? So we are replicating the same scenario, right? And if I go back and query this table on Hive, now what I will see here is, now as you can see, for 107, you have null record here, right? The London is basically under the city, right? So this is how we are able to rectify this. Now, earlier, without the AVSE file, this London would have come here under the name. But now, if you see here, all of them make sense. We didn't have anything for the name, so we have null. We have data for the city, so we have this data here. Now let's say if you, because name is deleted from the source table, we don't want to see name here. So what we can do is we can basically go here. We can open the AVSC file, right? So this is the AVSC file. And here what we have is we have name, we have city and other ID column, right? So name is not present. So what we can do is we can basically delete this, everything related to the name. So once you delete this, now this at this time, so what is happening is now here you have two columns. One is ID and city. So let me go ahead and save this, and we'll have to copy this to the HDFS location. So we forgot it last time. So we have copied this to the HDFS location. Okay. we have the file here. So let me delete this file first, and then we will copy this file to the HDFS location. So this should work. If we have this file, let me cat this file and make sure that we have the right set of metadata, right set of columns. So we have just ID and city. Now, the Hive table that we created using the .absc as the schema, right? That table will refer to this schema and it will say, hey, we just have two columns. So when you query this Hive table, now it will only display those two columns. It is not going to display those three columns. You can see here, right? It displays only two columns. So it is very easy to, make the changes. You don't have to drop the table. You don't have to recreate the table, anything. All you have to do is you have to go to the AVSC file, you delete the column, and that column will not appear here. If a source adds a new column, you just go to the AVSC file, you add that column, and then you push it to the HDFS location. Your table will pick up this data from the HDFS location, and it will displayed accordingly. So this is so easy. This is how we can do a schema evaluation. We can support the schema changes. So any project where your source is continuously changing the schema, adding a new column, deleting a new column, making the changes in the schema, maybe data types and anything else. So in those scenario, an Avro data file would be the right choice, right file format for you. And we have seen how easy it is to make changes to the schema. All you have to do is update this newly changed schema into the .absc file and then push it to HDFS. There is no other changes required. I will automatically pick up the newly changed schema from the .abc file, and it will display whatever is as per the .abc file. So that's it. We have made few mistakes here and there, but that's also good because these things can happen in real time as well when you're working on the project. And if you have a similar issue that has come up like we did, so right at that time it will be easy for you to recollect and say, hey, similar kind of issue happened in the course. So it's easy to resolve those issues, right? We always learn from our mistake. So that's it for this session. Thank you for listening, and I'll see you guys in my next class.